All right, finally we can get doing this. Okay, so now let's take a look at this as we're going through with our notes here. Okay, so where did I just put my notes? All right, fine. Okay, so Asana, you picked the number 2, right? So 2 is the base. Okay, and it says to use this as the exponent, so the exponent here is 5, right? So now, what would that look like as repeated multiplication? Not, no. Thank you. There we go. It would be 2 times 2 times 2 times 2 times 2, right? Okay. So now, what would that be in standard form now? No, it's not 2 times 5, because it's 2 times 2 times 2 times 2 times 2. What would that be in standard form? Okay, what's 2 times 2 is 4. Times 2 is 8. Right? Okay, standard form is the answer. So what's the answer here? So let's go. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. Times 2 is 32. Where'd you get 10?
How do you even
all right. Nonetheless, let's keep going. So if I have over here, it says I'm going to use the same base, but this time I'm going to use the exponent 4. Right? So what was it going to look like in repeated multiplication? You guys can go ahead and do this in your notes. So this is going to be 2 times 2 times 2 times 2, which is what? It's going to be 16, because 2 times 2 is 4, times 2 is 8, times 2 is 16. Okay, now continuing the pattern here. Okay, 2 to the exponent 3, and that's simply going to be 2 times 2 times 2, and standard form is going to be 8. So we understand what's happening right now, right? Okay, so you fill this in your notes. Get your notes out. All right, so now we have 2 to the exponent 2. Well, that's just simply going to be 2 times 2, and our standard form is going to be 4. Okay, so now my next exponent is 1. So I have 2 to the exponent 1. What do I put over here as repeated multiplication? Okay, just 2, right? Because it tells us there's only 1 2 there. So what's that in standard form now? It's just going to be 2. Okay, now, if I was to continue this pattern, what would the next number be here?
0.
Would be 0. So how would I write this as now an exponent?
2.
That's right. How would I write it as a power? What's 0?
2.
How would I write this as a power? Follow the pattern. So what would it be?
2 zeros.
2 zeros? No.
No, I said 2 zeros.
So let's say it properly.
2 exponent 0.
2 to the exponent 0. Okay? We got to say it properly, guys. Okay? So now, what would it be as repeated multiplication? So it would be nothing. We couldn't write anything there as repeated multiplication. But we do have a standard form. No. This tells us, hey, it's 2 to the exponent 0. Right? It doesn't mean that there's nothing. It means that there's something. What is there? Okay? And it is just simply 1. Anything to the exponent 0 is 1. Okay. All right, I agree now.
0 to 94. 0 to 0.
Okay. Anyways, going back to this.
Why does
Okay, just understand this. Okay, if you don't understand the logic, don't worry about it. As long as you don't know that anything to the exponent 0, no matter what, will always have 1 as its answer. Okay, because it just does. Just understand that. I don't have time to get into the logic beside it. Okay.
It's witchcraft. Just
All right. No, it's not witchcraft. Don't be such a bubble jumper. Okay.
Women
Stop
doing
it.
math is
Stop.
witchcraft.
Stop. I just need you to understand this. Okay. Anything to the exponent 0. the answer is always 1. Okay? Any number. Come up with a large number, Paul.
476.
476. So Paul comes up with 476, and we put it 476 to the exponent 1. Okay, I said 476 to the exponent 1. What's my answer? Right. So if I went over here, let's go over here. If I said 476, okay, Brianna, I need you to stop. Okay, 476 to the exponent 1, well, that's just simply going to be 476. Okay, but if I put 476 to the exponent 0, the answer is just going to be 1. 1 tells us that there's something there. Okay, 0, it's not 0. The answer is not 0, but it is 1. Okay? It is not 476 times 0. It's just 1. Means that there's something there. Yes? Right. Well, why didn't you say so in the first place?
Paul just watching the notes like,
Okay, well then
something's wrong, I can feel it.
Then try being here at school. I don't know where your copy is. I have a copy for you. Okay. I know I put it aside for you, Paul, but I guess I put it in such a safe place that I don't even know where it is. Okay. Oh, and then you also have a math test to write, Paul. Okay.
I was wondering if you would forget about that.
No, I cannot forget about it. Okay, so I'm sorry, Paul, you don't have it. I don't know where it is. Okay, anyways, let's go back to this. Okay, let's take a look at the next thing that we're going to do here. Okay, let's follow this pattern. Okay. Okay, fill in the following table to show decreasing powers of 10. So if I have 1 billion in standard form, this is what it is, and as a power, it is 10 to the exponent 9. Okay? Now, if I have a 100 million, if I write out 100 million, this is what it looks like, and it's 10 to the exponent 8. Okay, how do we figure this out? What exponent to use? When something like this, when we deal with powers of 10, to figure out what the exponent is, we just have to count up the number of zeros here. So 1 billion has 9 zeros. So as a power of 10, we just say, hey, it's 10 to the exponent 9. Okay. So now if I take a look at, let's say, 10 million, 10 million, this is what it looks like, has 7 zeros, so it's 10 to the exponent 7. So now let's write out 1 million. How many zeros would 1 million have?
6.
We'll have 6, so it'll be 1, and then 6 zeros, so 1 million. So now, what would it look like as a power? Right, 10 to the power 6, or we say 10 to the exponent 6. And then we continue this pattern as we go on. If I have 100,000, how many zeros are in 100,000? Okay, in 100,000, there's 5 zeros, so we'd say 10 to the exponent 5. 10,000, and if we just continue the pattern, well, that's 4 zeros, so it's 10 to the exponent 4. 1,000 has 3 zeros, so it's 10 to the exponent 3. 100, 10 to 2 zeros, 10 to the exponent 2. 10, what would 10 be? 10 would just be 10.
10 to the power of 1, this one was talking about.
Okay, so 10 to the exponent 1. So now, how about if we just have 1? It's just 1. And then what's our exponent? 10 to the exponent 0. Following this pattern.
10 degrees outside.
Okay. So we can make a similar table for the powers of any integer base except 0. Okay. So let's see. Okay. So let's take a look at this. So the number 1 can be written as any base except 0. So we can write this down. Okay? So at the bottom of your table, you've got these notes here. Write that down, please. Okay? At the bottom of your table, yes. Okay. So we can make a similar table for the powers of any integer base except 0. Use any integer you want. The only integer that we cannot use is 0. 0 cannot be the base. So if I have 7 to the exponent 0, the answer is going to be 1. If I have negative 5 to the exponent 0, the answer is going to be 1. If I have 4,252 to the exponent 0, the answer is going to be 1. Doesn't matter what the base is. The base can be any number except for what? 0. Okay? And the answer will always be 1. Okay. And this, I didn't include in your
Just in
notes.
degrees.
I mean,
Degrees. Instead of zero.
that's not a degree symbol.
Above there. Look at the way you wrote it.
The way I wrote it?
It's 7 degrees.
Right, but it's imagine that's a 0. Okay? So you write yours a little different. Okay. Alright, so this is something that we call the zero exponent law. Okay? The zero exponent law is a power with an integer base other than 0 and an exponent and an exponent 0 is always equal to 1.
Do we write
That is, no, you don't need to write it down. Okay? I'm just showing it to you. This is the zero exponent law. Okay? So, the base can be any number except 0, but if the exponent is 0, the answer is always 1. Alright, so let's take a look. Oops, that's not what I wanted to do. This is what I want to do. Okay, so example 1, evaluate each expression. You guys have this in your notes here. Okay? Or you're supposed to. What happened to the rest
You
of it?
don't
Okay.
have it.
Pardon me? Let's
You
see.
have it, you don't.
That's right. You have it, I don't. So let's take a look at this. Okay. So if I have, let's say A, I'm going to evaluate 4 to the exponent 0. What do we know 4 to the exponent 0 to be? It's just going to be 1, right? Now, let's take a look at this one. So if I have negative 4 to the exponent 0, now I've got a negative here. Thinking of what we learned last class, does this negative apply to the base? Or does it apply to the answer? Why does it apply to the answer? Pardon me? Because it's not in brackets. Thank you, Paul. You weren't here and you know this. Okay. So let's look at it this way. It could be the same. So this is the same thing as saying this. There's my negative. Well, I could have 4 inside the brackets. Right? Because this tells me that the 4 is positive and the negative is outside. So this means exactly the same as this. Right? So what's 4 to the exponent 0? 4 to the exponent 0 is 1. But what's still outside the brackets? It's a negative. So there's the negative. So then my answer here in this case is negative 1. Okay. Now, let's take a look at this one here. In this one, the negative is inside the brackets. So does that mean that negative applies to the base here? So the negative applies to the base, so what's my answer in this situation? It's just going to be 1. So do you understand the difference between these two? Right? Between B and C, and that's what we focused on in last class. Okay, good job, Paul. Alright, so now let's take a look at this one here. Okay, let me just clear the annotations. Okay, so now it says, example 2, write 3,452 using powers of 10. This is going to be kind of slightly confusing, but what I'm going to say is here, you know what? Let's use place values. And because I put a star beside it, that means it's important. Okay, so let's use place values. Let's take a look at the digit 3. 3 is in what place value? Pardon me. So 3 is in the thousands place value. That makes sense, right? So how would I write 3,000? Or how would I write 3,000s? Say that again. Thank you. So I would write it like this: 3, 0, 0, 0. 3 zeros, right? Okay. Now, could I also write this? Would this be the same thing?
Yes.
3 times 1,000? Okay. Could I also write this with a base of 10 or a power of 10? What would this look like with a power of 10? Yeah, okay. So we can write this 10 to the exponent 3, but what about this? This still has to be there. So could I also say 3 times 10 to the exponent 3? Alright? You guys with me so far? So we wrote 3,452. We're going to use our place values. So we took the 3. We said the 3's in the thousands place value. Well, this is what it would look like. Right? We're breaking it down. Let's take a look at the next number. 4 is in what place value? 4 is in the hundredths place value. And so then 4 hundredths will look like this. 400. Okay, could I also write this like 4 times 100? So now let's write it as a power of 10. What would that look like? 4 times 10 to the exponent 2? Yeah. Right? Okay. The next number is 5. 5 is in what place value? 5 is in the tens place value. So 5 tenths, what does 5 tenths look like? It looks like 50. And I could write it like 5 times 10.
I think it was actually about this in grade 3 or 1, but like, when do you add the TH in the words again?
When we're dealing with decimals.
Yeah.
Okay, so now we could write 5 tenths like this. 5 tenths we know is 50, which we also get by 5 times 10. And how could I write it as a power of 10?
Or 1?
5 times 10 to the exponent 1. Absolutely. Now, let's take a look at the next one. 2. 2 is in what place value? Ones. So 2 ones looks like what? Just 2. Right. So now, 2, how could we write it like this? Right, so we can just say 2 times 1. How can I write it now? Oh, close. Absolutely. So then we go 2 times 10 to the exponent 0. Because we know that anything to the exponent 0 is 1. Right? Oh, we're almost done. The final answer is that what it looks like is now we take all of these and we add them together. Okay? This part here was just help us to identify this part. So now 3,000 was like 3 times 10 to the exponent 3. And what are we adding to it? We're adding 4 times 10 to the exponent 2.
Did you just say 3,000
No, where this is the question's asking, write this number. We have to write this number using powers of 10, which is this over here. We first have to find the powers of 10, which we did. Now we're going to add it all together, which is like this. And the next one is 5 times 10 to the exponent 1. And then the next one is plus 2 times 10 to the exponent 0. And that's our final answer. Okay? So write this number, writing it as powers of 10, looks like this. Do you guys understand? Okay? doing this work right here just helped us to identify the powers of 10. Okay? So, like what I want you guys to understand, what we're doing so far is not very difficult. Okay? Alright, let's take a look at the next one. Okay? Moving on. You guys with me so far? Yeah? I can go ahead? Okay. Alright, let's take a look at this. Example 3.
A buffalo.
Okay. Head smashed in Buffalo Gym. You guys ever heard of that place?
Yeah.
It's an amazing place. Did you get a chance to go there?
No, you're
Okay. So this place called Head Smashed in Buffalo Jump. Okay. It's a UNESCO World Heritage Site in southern Alberta. Okay. Basically, it's this large cliff. And what the indigenous people of southern Alberta used to do, because you know that they were called the Plains Cree, okay, or the Cree people. And one of the things that they depended on, you guys learned this, is the buffalo, right? They used the buffalo for everything from clothing to food to building materials, whatever. They used it. They used everything of the buffalo. Nothing got wasted. Okay. So the way they would hunt buffalo, one of the ways, is they would round up the buffalo and stampede them over a cliff. And so it's called head smashed in buffalo because what happened? They're running, they fall over the cliff, and they smash their head in.
Imagine dying like that.
Alright? And
Yeah.
so now, head smashed in buffalo jump in southern Alberta is the biggest place in Alberta that's found. There's other places throughout Alberta where they would have these other buffalo jumps, but the one in southern Alberta was the biggest one. Okay, this site covers 600 hectares and contains cultural remains used in the communal hunting of buffalo. Head smashed in was first used for hunting bison at least 5,700 years ago, and perhaps as early as 10,000 years ago. It is estimated that close to 60 million plains bison roamed the prairies prior to the Europeans' arrival in Western Canada. Less than 100 years later, fewer than 1,000 animals remained. That is a disgusting fact.
darn white.
Okay? When you had 60 million roaming the prairies, and the Europeans came in, the Europeans almost wiped out the entire population of buffalo. We are nowhere close to having the amount of the population of buffalo as we once did.
That's how buffalo when we went to a corn roast. They just
Right.
chilling.
And because now you're starting breeding programs. Remember what we were talking about in science? We now have breeding programs in place. We have national parks in place that are specifically protected areas so that buffalo can roam and buffalo can reproduce and so on. Yeah. All right. Anyway. Now, it says use powers of 10 to write each number in the above paragraph. Okay, so let's take a look at the above paragraph. Let's first of all underline all the numbers that we see there. Okay, so what's the very first number that we come to? 600. Okay, so underline it. What's another number? 600. Okay, it's first used for hunting buffalo at least 5,700 years ago. Okay, and then it says, and perhaps as early as 10,000 years ago, and then 60 million, and then, what's another one?
100.
And 100 years later, fewer than 1,000 animals remain. Okay, so the very first one, okay, it says use powers of 10. The very first number that we come to is 600. Okay, let's write 600 as a power of 10. Okay, 600, what's one way to write 600? We could say 6 times 100. If we identify that as 600, well, how could I write this then as a power of 10? 2. That's right. So we can say that this equals 6 times 10 to the exponent 2. What's our next number? 5.7k. 5,700 years ago. You're right, we could say, yeah, 5.7k, but our number is 5,700. So 5.7k does work. K is Latin for kilo, which means thousand. Okay, so 5,700. So let's first of all take this number, break it down a little bit more. So when you start with the 5 is in what place value? 1,000. So it's 5,000. So we could write 5,000 as 5 times 1,000, which we could write as, how else could I write this number? Right, 5 times 10 to the exponent 3, right? So that part is done. And then what's the other number that we have there? So I got 700. So 700 I could write as 7 times 100, which then I could write as 7 times 10 to the exponent 2. But am I done yet? What's left to do? I got to take these two numbers and I can have to add them together. So then 5,700 would look like this. 5 times 10 to the exponent 3 plus 7 times 10 to the exponent 2. So far, so good. Can I erase that? I just want to finish this up with these guys. Where? You can go to the back of the seat with Isana. You can come up here wherever you feel comfortable. Hey guys, this is Richter, Pastor Derek's wife. You guys know her, right? So she's going to be in here hanging out with you guys because Pastor Mark didn't want to be here with you guys today. He said,
The way you said that.
no.
Wow.
That's what he just told me at the door. I don't want to be with these grade 9s.
Dang. What did he do?
You know why? You know what else he said? He said because they're too awesome.
Cap.
He said these grade 9s are too awesome and I'm not
Cap.
awesome enough.
No.
So he's going into a meeting to be more to wrap up on awesomeness so he can join you guys. Okay, alright, anyways, do you guys have this copy now? Alright, can I erase this? Yeah? Okay. So I'm gonna erase it because anyways, because I need room. Okay, so what's our next number? Okay, our next number was 10,000. So now let's write 10,000 as a power of 10. What would it look like as a power of 10, Irene? What's 4? Right, so what would this number look like as a power of 10? You're right, the 4 is needed in there, but where is it needed? So in other words, give me the whole thing. Right, we need 10 to the exponent 4, but what's missing? How about this? Would it be 1 times 10 to the exponent 4? That's needed in there. Even though the 1 is kind of redundant because 10 to the exponent 4 is 10,000, but if we're writing as a power of 10, if our number is 10,000, then we still have to say 1 times 10 to the exponent 4. Exactly. All right, good. And what's our next number after that, Paul?
Words, numbers.
Yes, you're right. Words.
Stuff.
Words and stuff and numbers. 60 million. Okay.
Words.
So 60
Words.
million is our next number there. Okay. So 60 million. Is this 60 million?
No.
What number is this that I've written down? 60,000. So what's needed? 2 more zeros?
More zeros.
We need more zeros. How many zeros do we need? Okay, first of all, we're dealing with 60 and then million. How many zeros in a million? You're not listening. You didn't answer my question. I said, how many zeros in a million? That was my question. How many zeros in a million? Thank you, Asana. You're the only one that I can count on.
I said that.
No, you said 7.
No,
Okay.
I said 6.
So, 7 and 6 are both, 7 is technically correct, 6 is more correct. Because my question specifically was, how many zeros in a million? And in 6, there are 6 zeros in a million. But in 60 million, how many zeros altogether? Oh my gosh. Now we know how Jesus felt when he was with his disciples. And he's like, how much longer must I stay with you guys?
Some of y'all are the reason shampoo bottles have instructions.
Yes. Alright. So we talked about addition, now we talk about Christianity. Okay, so 60 million. In a million, there are 6 zeros. So because the number is 60, so there's another 0, so that means in 60 million, there's 7 zeros. So now, we could look at this like this. So if I have 6, okay, I could say, hey, now can you guys tell me, what's this going to look like, guys? Okay, all right, you know what, let's go back. I could say, if it's 60 million, I could say that's the same thing as saying 6 times, like 6 times 10 million. So now, how could I write this number as a power of 10? Say it a little louder. Right. So then this would then become 6 times 10 to the exponent 7. Okay. So far, so good, right? Okay. And then, what's our next number that we see there? Okay. We see 100. 100 then looks like this. So what is this now as a power of 10? Oh, you're close. We want to write it like a power of 10. Kind of like what you see up here. Say that again. 10 squared is needed, but what are we missing? Because the number is 100, so it has to be 1 times 10 to the exponent 2. Okay. And then what's our last number? Okay. 1,000 is our last number. Okay. Irene, what would that be, Irene, as a power of 10? We have 10 to the exponent 3, but how are we going to write it as a, because my proper number is 1,000, so what do I have to have in my answer? Yes, I have to have the 1, right? Take a look. 10,000 was 1 times 10 to the exponent 4. 100 was 1 times 10 to the exponent 2. How about 1,000? What's 1,000 going to look like? 1 times 10 to the exponent 3. Okay. Good. And we are done. Okay, so that's our lesson for today. We'll finish this up in tomorrow's class. So obviously no math homework, but you guys will do the work. And
I'm so proud of myself. I didn't get lost.
of course not. You got me lost.
That's new for me.
Okay. All right. So guys, Mrs. Richter is here with you guys.